transform. My name is Azimah binti Zainal Abidin and my partner group Nur Aliza binti Mazam. So for the lab transfer function, Z transform. Okay, for question 1, this is the procedure anti-exercise C. So first we need to calculate and convert to transfer function. So this is calculation for system 1, system 2 and system 3. Okay, for system 1 example, from equation we need to calculate and convert to transfer function, and then need to find yz over xz, and then we calculate and we get the answer as shown in the lab sheet. Okay, for system 2 also same. So this is answer, and this is answer for system 3. Okay, for question 1, exercise B, we use this coding in MATLAB. So we run the coding. Okay, as you can see here, this is a value that show in the command window for root number 0, root 3, denominator negative 0.5. Okay, next. For question 1, exercise C, we use this coding MATLAB, which is root 1 number, root 1 denominator, and we use this function in the MATLAB. So we run the coding. As you can see here, the value for K3 is 1. So this is the result for R3, P3 and K3. Okay, next for question 2 part 1, we use this coding, which is we need to plot Z-plane, plot H1, H2 and H3. So we run the coding. Okay, as you can see here, this is a result we get for Z-plane plot H1, H2 and H3, which is y-axis is imaginary part and x-axis is real part. So we can see the 0 and full 0 input and this is a 0 input float. Okay, for next question, I will pass to Nur Aliza binti Mazam.
Okay, I will explain for question 2 part 2. Okay, for question 2 part 2, this is the coding. For question 2 part 2, we have to use the Z part 3 file to generate the plot frequency response and response magnitude of system 1, 2 and 3, and then we have to use the ABS function to find the magnitude of the zeros. What can you conclude from the filtering effect system 1, 2 and 3? Okay, from the question, okay, this is the coding, the full coding for the Z part 3. Okay, for the system 1, this is the numerator for the coding, and then this is the denominator for the coding. And then we have to use the quick Z function, and then same goes to the system 2 and system 3. And then we have to plot the Z plane and magnitude response for the system 1, system 2 and system 3. And then we have to run the coding. Okay, as we can see here, this is the result for the part question 2 part 2. Okay, this is the magnitude for the magnitude response for system 1, and then this is the magnitude response for system 2, and then this is the magnitude response for the system 3, and then on the right side, this is the Z plane plot for system 1, and then this is the Z plane plot for system 2, and then this is the graph for the Z plane plot for the system 3. Okay. So we go to the exercise. Okay, for exercise C, we have to use the Z part 4 file. We have to use the filter to filter with the minimum number of zero and poles. So we have to observe the zero level spectral point and denormalize them with pi. And then we have to apply the Euler formula cos plus j sine on the MATLAB function poly to design the filter. So for part 4, for exercise C, okay. For exercise C, this is the fully coding for the Z part 4. Okay, so on the system, we have to use the filter function. Okay, and then this is the filter function. Use the poly function to find the coefficient of the characteristic polynomial of the matrices Z. And then okay, and then we have to plot the system, and so we run the coding. So this is the fully coding for the Z part 4. Okay, from the result, as we can see here, this is the filter 1 for the normalized H1, normalized system 1. As we can see here, this is for filter 1, and then this is the filter 1 for the normalized system magnitude response for the system 2. And then for the Z plane plot for system 1, and this is the Z plane plot for the system 2. On the Z plane plot for the system 1, as we can see here, the zeros are on the left sided, and then while for the system 2, the zero is on both sided. Okay, so as for the discussion, answer all questions in procedure exercise and discuss the task based on experiment data and experiment result. For the question 1, we analyze system 1, 2 and 3 to determine the transfer function by performing Z transform on impulse response. Then the value of the system, we evaluate denominator polynomial as well using root function coding example, and the result we get the same as calculation. And we convert the transfer function filter parameter to 0 for gain, from which is Z plane exists Y imaginary part, and exists X is the real part, which is Z plane H1, H2, H3. So the relationship between the location of the pole and the 0 is a causal system. For the question 2, when the S approaches a pole, the denominator of the transfer function approaches 0, and the value of the transfer function approaches infinity. In addition, 0 to the transfer function has the effect of pulling the root locus to the left, making the system more stable. The relationship between the location of the pole and the magnetic response characteristic for the causal system is because the pole inside the unit circle contribute an exponentially decaying term to the magnetic response. Next, we can see the effect of the zeros and pole and their relationship to the system filtering effect. At the plot normalized magnetic response, also change the Z plane as the figure question 2 exercise C, with Z plane H1 plot 0 at the left side, while H2 at the Z plane plot 0 at the both sides. Okay, for the conclusion, as the conclusion from this lab, this is the conclusion for this lab, for Z transfer lab. As a conclusion for this lab, Z transfer, we understand basic digital signal frequency characteristic and analyze Z transform, system transfer function and frequency response. Besides, we need to understand and verify the basic concept of Z transform and the relationship between the system transfer function to the frequency response. The S in the transfer function in the S plane that is obtained from the Laplace transformation, while HJW is the transfer function obtained by Fourier transformation. Relation between two is S phase plus JW. Next to understand the effect of the zero and a pole in the system transfer function and the frequency response. In addition, pole to the transfer function has the effect pulling the root locus to the right, making the system less stable. Addition zeros to the transfer function has the effect of pulling the root locus to the left, making the system more stable. That's all from us. Thank you.